From a circular piece of paper with radius BC, Jeff removes the unshaded sector as shown. Using the larger shaded sector, he joins edge BC to edge BA without overlap to form a cone of radius 12 centimeters and volume 432 pi cubic centimeters. What is the number of degrees in the measure of angle ABC of the sector that is not used? So we need to find out this angle equals to how much? What is that angle? That is what we need to find out. Okay. Now what we have been given, let's read this again and try to understand. We have a sector here and the sector is transformed to form a cone. So in this scenario, when a sector is transformed to a cone by just joining the radii without overlap to form a cone, then how the relation between these two will be, let's try to understand that. Now let us say the sector we know will have radius. So the radius of sector will become lateral height or L of the cone. This is L of the cone and this is radius of sector, and this is the radius of cone, and if we join this is height of the cone, and we know L square equals to RC square plus, if I take it as C, it's C square. What else we know? Radius will become slant height. Not only that, the length of the arc, or we can say in sector, so we have, I'll write down here, arc length is equal to circumference of the base. So this length, whatever we have, when we fold this, will become into this shape. So this length of the arc should be equals to circumference of the base of the cone. So what we can write down then, arc length is equals to circumference of base. Also, area of sector will become curved surface area of cone. This is the area we are talking about. Now this area will become the curved surface area of the cone. Now these are the relationships. Combining with the relationship here, we can easily find out what is the value of the number of degrees in the measure of angle ABC that is not used. So let us leverage this and try to find out the value of theta. So first I will try to get all the information whatever is given for the cone. We have been given that volume equals to 432 pi. We also know radius of the cone is equals to 12 centimeter, and we know volume is 1/3 pi r square h. That is the formula for volume of cone. Volume equals to 1/3 pi r square h. We know radius, so we have to find out what is the height of the cone. So that we need to find out first. We will do that. Then we will go and find out L. Once we find out L, we know that that is equals to our radius. Now this we have done. Then we will go to either any one of this. Leveraging this, we should be able to find out the theta. So let's go ahead and first find out height of the cone. After that, we'll find out what is the lateral height of the cone. V equals to 432 pi equals to 1/3 into pi into r square 12 square into h. I can cancel pi and pi. I will have 1296 equals to 12 into 12 into h. When I simplify that, I will get h equals to 9 centimeters. So we have height of cone as 9 centimeters. Once we know height of the cone, we can easily find out L square, lateral height of the slant height. Slant height we actually call it as the slant height of the cone is given by r square plus h square. So that is 12 square plus 9 square, which is equals to 15 square. So we can write down L equals to 15. L equals to 15 means we know that radius is equals to 15 centimeter. We know that the radius of the sector is equals to 15 centimeter. So once we understood this, now we can go to arc length or area. Any one of them we can use the other condition to find out the theta value. Let's go ahead and do that. Now once we understood that L is equals to 15 and h equals to 9 centimeter, we got it as 9, so we can write it down. 9 centimeter and L is 15 centimeter. So now we will use the other condition which says that area equals to sector area equals to area of sector equals to CSA of cone. Sector area equals to cone CSA. Now what is the formula for sector area? That's equals to theta by 360. Certainly not this theta, then you will get confused. So I'll remove this part. Theta by 360, where we are talking about the theta is here. This whole thing is theta. Theta by 360 into pi. Theta is in degrees into r square. Just now we got the radius is 15. 15 square equals to pi into radius of cone is 12 and L slant height. If I said earlier lateral height, then it's actually wrong. It is slant height. I just got confused. So pi and pi will cancel out. We can easily calculate what is theta. Theta equals to 115 will go away. We will have 360 into 12 divided by 15, and that is equals to 288 degrees. Now what we want is the reflex angle of this. So that is equals to 360 degrees minus 280 degrees, 88 degrees, which is equals to 72 degrees. So let's have a recap of this problem. We have been given a sector and we have been told that this sector was formed into a cone of radius 12 centimeters and the volume is given. The idea is that we can easily calculate the height. Once we got the height and radius, we can find out the slant height. But the slant height of the cone is equals to the radius of the sector. Now once we got that information, then we can leverage the any other two conditions. One is sector area equals to cone CSA or arc length of sector. Arc length is equals to circumference of base of the cone. So any one of them we can leverage and we can calculate the value of the central angle theta. Then in that scenario, what we want is reflex angle, that is 360 minus 288, which we got it as 72 degrees.